Hello, everyone, and welcome to Houston Techfest 2020, the virtual edition. Before we get started, I want to make you aware of a feature in the presentation that will make the session more interactive. Please make note of the question mark icon on your presentation screen. Clicking the icon will open the question and answer feature, which will allow you to send the moderator questions to be delivered to our presenter at the appropriate time. So please feel free to post anytime during the session. We are also excited to let you know that CodeMag is giving everyone a free subscription. You can follow the link posted in the Q&A section. We are proud to present Jay Sawyer, Principal Consultant at Catapult Systems, who will be sharing intro to dependency injection in .NET Core. Jay, take it away.
Alrighty. Thank you, Kenneth. Welcome, everybody. It is good to be here virtually for yet another Tech Fest. And really excited to be talking to you today about dependency injection, well, very specifically in ASP.NET Core. So really, as we get started, let's take a look at our agenda. We're going to do just like a quick overview of what dependency injection is and why you should care. And from there, we're going to get right into using dependency injection in ASP.NET Core. And I'm going to show you a couple of different ways. I'm going to try and make it very demo heavy. So you'll get to see a lot of code, which is a good thing. We all love code. And then we'll also talk a little bit. I'm probably not going to do the dependency injection in Azure Functions just due to time, but do know that you can do dependency injection in Azure Functions. Our goal here is really to provide a high-level intro to dependency injection, very specifically in how you use it with ASP.NET Core. So what is it? Well, dependency injection is a technique. It's not a framework, although there's a bunch of DI frameworks. It's a technique where one object, or in this case, a framework, right? The .NET Core framework will do that. There's a bunch of others. Supplies the dependencies of another object, and they are injected in, hence dependency injection. All right, that's interesting, but what do we mean by this dependency thing, right? So, I have dependencies, I have all these DLLs. Is that what we're talking about? No, it's not. In this case, what we're talking about is an object, or really more specifically, a service that can be used by another object. And typically, you will see these implemented as a service interface. So think of maybe something like a repository, right? A repository is an excellent example of something that you would do as a dependency. And then once you have the dependency, that injection is the passing of the dependency to the dependent object. The dependent object being the one that consumes the service. So going back to our example of a repository, right? Most of your pages are going to consume that repository, consume one or more repositories in order to read and write data. So that repository would then be passed into the dependent object that will consume it. The client is that dependent object that will use the dependency, and it is one form of inversion of control, or IOC. Why is that? Because typically, right, when we're talking about building applications, it is the client that controls its dependencies, right? It will instantiate them by saying, I want a new, bank repository, right? In this case, that's not what's happening, right? The control is being handled by the framework, and the framework is passing it the repository that it's going to use. Now, it sounds complicated. Why would we do that? What is the purpose of this stuff? Well, number one, kind of first and foremost, it really reduces the coupling between the components. You're no longer directly instantiating your services, right? They're being handed to you. So you have a lot of flexibility, and you can actually swap those out without having to change, very much, if any, code at all. Ideally, no code, but, we know we live in the real world, not the ideal world. Another reason is that it simplifies testing, particularly unit testing. And we're going to see this towards the end where we go in and we actually use our service interfaces and mock them out for unit tests. So dependency injection makes it very easy to have stubs or mocks to be used in place of real objects. And so this solves a whole lot of problems around unit testing. Now, it can, not always, but it can make concurrent development simpler. And I say that it can because it is true, but it requires some management and architectural forethought ahead of time. You can't just get in there and have a team of 10 devs and just start whipping stuff out. Of course, we know how well that always works in the real world. But if you have good management and good architectural planning ahead of time, you can go ahead and define those service interfaces, define, very simple mock objects, and have, one set of devs or one dev do this service, another dev do that service, while yet still yet another dev is actually doing the clients. So it can make concurrent development simpler by allowing you to break apart those dependencies, hand them off to different team members, and bring them back together relatively simply. And it also can, not always, but it can make it simpler to understand dependency usage across a large code base. And that's really kind of a happy side effect, because you have to define which dependencies are going to be injected. Typically, and as we'll see with ASP.NET Core, that's done via constructors. So it becomes very easy for you to go in and say, you know what, where is this dependency used? I'm going to scan all of my constructors. And so you can have tools that go ahead and do that and scan those, and you can see very easily what those dependencies are, instead of having them buried in the midst of the actual implementation code, which can be very hard to identify and figure out. Excuse me for 1 second while my dogs are barking. Alrighty. They don't listen very well. Now, with that said, there are some challenges with dependency injection that you really need to be aware of. Number one, kind of the first thing is it can be more difficult to follow the code. This is a real challenge if you use IDE tools like Go to Definition, because things like Go to Definition, they won't go to the actual implementation. They will go instead to the definition of the interface. So yeah, that's not actually very helpful sometimes. Also, it does require a bit more upfront planning and potentially a bit more upfront development, because you're defining a service, you're defining an interface, and you're declaring and defining those dependencies. It can also sometimes feel like black voodoo magic. This is particularly true when you're first getting started with dependency injection. And you have these things just being handed to you, and where are they coming from, and how is all this working, and how am I getting my repository, right? So it can feel like black voodoo magic for those of us who are real control freaks, and being developers, we tend to be. That can be a little disconcerting, but once you get used to it, you understand what's going on, you understand how all this is working, it can be pretty straightforward. Last is that it can lead to some really very unwieldy constructors, right? If you have a lot of dependencies that a particular class is doing, you can have this massive constructor with all these dependencies being passed in. Now, that said, I would argue that if you see this, if you start having these unwieldy constructors, if you start seeing that you have a client class that has 20 different services being injected into it, that right there is a code smell, right? You should go, yeah, that doesn't smell right. So It can do that, and typically, though, if you're in that position where you have those unwieldy constructors, you really should look at simplifying it, because in most of those cases, probably 99.99% of those cases, you're violating single responsibility principle, right? And you should look at refactoring that and refactoring some of that stuff out to simplify it so that you don't have these massive unwieldy constructors. Now, in ASP.NET Core, how do you get started with this, right? So, there have been dependency injection frameworks around for a long time. We had them in, .NET Framework, and we've had them for a long time. But in order to do that, you had to go in, you had to get this, you had to get that, you had to go up to NuGet, right? Once we had NuGet, before that, you had to download them. It was all kind of a nightmare, right? And then you had to select which one. But with ASP.NET Core, what they've done is they've actually built it into ASP.NET Core itself. There's no separate libraries, there's no separate utility or anything like that. It's just there. So all you have to do is go in and create an ASP.NET Core web app. That's it. And then start coding. You configure your services in Startup, configure services. You define your injected services in your constructor, or by using the @inject directive in an MVC view. And it's just there. And in fact, a lot of the services and features that you use in ASP.NET Core are built on top of dependency injection. So whether you're actually using it or not for your own code, the ASP.NET Core framework is already doing it for you. So you might as well take advantage of the goodness that's in there. So let's go ahead and actually jump right into some code and get started. And what I'm going to do is I'm going to start off. Now, this right here is a brand new, freshly built, untouched, like right from the wizard, ASP.NET MVC application that I created just before this presentation. You can see that it is Web App 9, so I've done a few of these, right? So there's nothing special about this. This is how it comes right from the wizard. And you'll see this configure services right in here, and look at that. Services, add controllers with views. So it's already doing that. So let's actually run this real quick. Go ahead, hit F5. Takes it just a second. And here we go. And you'll see this is pretty much about as simple as they come, right? This is the default kind of out of the box experience with a brand new ASP.NET Core app. So now what we're going to do is we're going to go ahead and define our own services to inject. So how do we do that? Well, we have to add some code. Oh, darn. So I'm going to come in here, and just for the sake of keeping things nice and ordered, I'm going to create a new folder called services, right? And I'm going to cheat. I'm going to put both my interfaces and my services in here. You may want to segment them out. There's a whole, we could get into, no end of rabbit holes talking about what the best way to do it is. The reality is it's a consulting answer. It depends. So I'm going to come in and I'm going to add a new item. And in this case, I'm going to add an interface. So I'm going to call this the I say hello interface. All righty. And I'm getting a request to zoom in just a bit. So what I'll do is I'll increase the font size just a hair. There we go. So here's our interface. It is I say hello. You can probably guess where this is going. Because this is the first demo, of course, I have to do the obligatory hello world. And I'm going to define a string, and it's going to be, say, hello, and it'll take a string to whom. All right, so we have an interface. Let's go ahead and make it public. It defines one method, say hello. I could certainly put properties on here or whatever else that I want, right? Just like any other interface. And then I'm going to come in and I'm going to add new item. This will be our class, and I'll call this my say hello service. Nice, simple, sweet. It is going to implement my interface. I say hello. All right, and let's go ahead and finish it up. Implement my missing members, right? And then I'm going to return, hey. So there we go. What did I put a space in there? There we go. All right, so very simple, not a heck of a lot to it. Let's go ahead and make sure it builds. We build, that's good. So let me go ahead and I'm going to come in here and I'm going to come into my view. And I'm going to use that @inject directive that I told you about, right? So I'm going to say @inject. What am I going to inject? What service? I'm going to inject the I say hello service. So I say hello. So what you're doing is you're saying I'm injecting this interface, and then what is it going to be called? What is the variable name within the page? And I'm going to call this hello service. Right. And so now I can come in here, and in this H1, I can say @ and you'll notice that the hello service is there in the IntelliSense. And oh, there's my say hello. I'm going to say Techfest. Hey. So there's one way to do it. This is how we do it in our actual ASP.NET Razor views. But of course, we will be doing most of our code in the controllers, right? Because we don't put a whole bunch of code in views, do we? Please say no. So I'm coming here into my controller, and I'm also going to inject the same say hello service into my controller. Now, the one thing that I do have to do here is I need to go ahead and declare this as a member field. And since it is only set in the constructor, you can go ahead and declare that as read only. All right, so this will let me set it in the constructor, but I can't set it anyplace else, which is a good thing. It's typically what we want. And I'm going to set that to the passed in service. I'm going to set a breakpoint here as well so that we can see this happening. And then on this, I'll just do a debug.writeLine. Hello service, say hello, debug window. There we go. So I've gone ahead and I've defined my service, my dependency. I'm injecting it in here. So let's see it works, right? I said it was built in, right? So let's go ahead and hit F5. And what you'll see is it goes boom. Now, why did it do that? Needless to say, I knew this was going to happen. But this is one of those things that you will run into a lot when you're doing dependency injection. So I've gone ahead and defined the service. I've defined the interface. And I'm consuming them, but I didn't actually register them. Remember that step that I mentioned about registering? So when you do that and you forget to do it, you will get this exception, unable to resolve service for type while attempting to activate blah. All right, so if you see this right here, this invalid operation exception, unable to resolve service, blah, 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 right? You will know that what you forgot to do was register the dependency with the framework. So let me stop that. And I'm going to come in here into the startup. And what I'm going to do is I'm going to say services.add transient. And we're going to get into what add transient means and some of the other different flavors of this in just a minute. So I'm not going to go into it now. I'm going to say I say hello, and this will be my say hello service. So now what I've done is I am telling ASP.NET Core that when it sees a request for I say hello for this particular interface to inject, to replace it and to inject this particular class. Now that could be any class as long as it implements that interface. Let's go ahead and save that. And I'm going to hit F5. And it should hit my breakpoint. There we go. So you'll see here's my breakpoint. Here's my hello service. You can see the class type in there. Web application 9, services, say hello service. Go ahead and hit F5. You'll see that it said, hey, Techfest, hello world. And you'll see here, hey, debug window, hello world. So you see that it is actually getting called. The code that we wrote is actually getting executed as well. And you were able to see both using the @inject declaration or directive, @inject directive, as well as passing it into the constructor of a controller. You'll also notice here this logger, that's just baked in. ASP.NET Core will automatically kind of bake in logging and go ahead and inject it for you by default, which is kind of cool. So let's go over. And then, so we've already seen a little bit about this, right? How do you configure those dependencies? You go to startup.cs, you start adding services into your configure services. Now you have a bunch of different overloads in there that allow for container created services, or even to specify a factory method to create the service. So if you want to do some sort of initialization or something like that, you can actually do that when you register the service, and it will call that factory method for you every time it actually executes. So we see this here, right, with this add transient, and we're saying go ahead and use this factory method. Now this isn't necessary because what it will do, what the ASP.NET Core DI framework will do is it will actually walk the dependency tree. So if one dependency needs an additional dependency, it will walk and supply all of those dependencies from the appropriate context. But in this case, we're manually supplying it. So let's go ahead and go a little bit into adding services. I'm going to flip over to the other demo app, which is right here. Now here we have, and this is going to be kind of the demo that we work with over and over again. It's kind of the same thing. It's a very simple type demo, but I have a whole bunch of services defined, and I have a couple of interfaces defined, and we're going to be playing around with this. So you'll see here in my startup, there we go. You'll see that I'm doing, well, cookie policy options. That's actually something that's injected, right? So you'll see I'm adding services in here. So you'll see right here, this is that particular factory method. Now this is a full-blown Lambda, so it can actually be pretty complex logic. But you have to be really careful because this will get initialized. Anything that you have in this factory will actually get called anytime you request that dependency. Or actually, let me be a bit clearer. Anytime you request a new instance of that dependency. And in this case, because it's transient, it will be every time that it's requested. You see here that we have some additional logic where we're creating an array of transaction types, and in here, right, we have additional types of transfers that we are then specifying in our fund transfer service. I'm adding logging. We'll talk about add HTTP context accessor, and away it goes. So let's take a look at one or two of these dependencies real quick. All right, so what you'll see in here is that in the dependencies, I'm actually writing to the debugger every time I create an instance of it. So we'll see these instances get created. And you'll also see in my controllers, right? So in my fund transfer controller, you'll also see that I have my different constructors actually having the dependencies being passed in, and then it is using them. So let's go ahead and run this. Okay, and so what I want you to do, let me go ahead and clear this out so you can watch the debug screen down here, because that will actually show us all this stuff kind of going on behind the scenes, right? All the magic goo, that black voodoo magic that ASP.NET Core is doing for us. All right, so if I come into fund transfer, you'll see this account logging service gets created, the account service gets created, the fund transfer service gets created. All right, I come in here. And you'll see again, we have more of these services getting created. So every time I'm going in and doing something, it's creating those dependencies for me, right? And you'll see that there is a little skip in here. So this is actually a child dependency. Okay, so you see all those, and it's just being handled for you. Once you register them, once you declare them in the constructor, you register them in the startup. It handles all the details for you, and they just get provided. So let's go on and let's talk about dependency lifetime. Now, when you looked at those dependencies that I had in there, everything was done as add transient. And this is kind of the default. And so what this means is it's really letting you control the lifetime of that dependency. And add transient means it has a transient lifetime. A new instance is created each time the dependency is requested. So every time you see that dependency, every time it's there in the tree, it will create a new instance of it. And sometimes that is appropriate. But sometimes, particularly in an ASP.NET style application, it's not, right? And so there is another lifetime. This is add scoped. And add scoped will create a new instance for each request. So if you have multiple clients of an individual dependency that are using that dependency within the context of a single HTTP request, it will only create one instance. And so you'll actually see this for some of the default behavior for some of the default dependencies that ASP.NET Core recognizes. For things like repositories, this is typically appropriate. For DB context, this is typically appropriate. HTTP client, this is typically appropriate. Right? You create one instance of it throughout the lifetime of the request, whoever is using it. But you also have this add singleton. Now, an add singleton will create an instance on the very first request and never again. So you're like, wait a minute, how different is that from a static class? Well, number one, it's not static, right? You're still creating instances. It's still a standard class. But number two, right, statics are a type of really tight coupling. So you can kind of have the benefits of statics where you have that single instance, but you have all of the niceness of dependency injection. Plus, right, if you decide that maybe it shouldn't be singleton, you can go ahead and change it to scoped or transient, and you don't have to change any of your client code. Right? In fact, your client code is completely blissfully unaware of whether it is transient or scoped or singleton. It doesn't know. It doesn't care. As long as it gets the client that it needs, it's happy. We also have this thing called triad enumerable, and this one's actually kind of fun because this allows you to define enumerable services where there can be more than one implementation. And we actually see this in our transfer service, right? We have multiple different types of transfer services. And so we'll actually see how we can use triad enumerable with those. You'll also have several variations of triad. So triad transient, triad scoped, triad singleton. And those will add something if something else isn't already registered. And you may wonder why you want to do that, right? Well, the reason you might want to do that is when it comes to registering these things, last in wins. Right. So, and you'll see this a lot in the ASP.NET Core framework with kind of the dependencies that are built into ASP.NET Core is they will try add. And the reason they try add is because they allow you to override the behavior of those dependencies. But if you don't do it, right, they go ahead and add the default implementation. Right. So that's where those different triad flavors can come in and are actually quite handy. So let's go ahead and take a look at some of the various flavors of add. So let's go ahead and flip back here, and I will switch over to demo 3. So flip. It's working in the background, so let me go ahead and ignore that. All right, so let's come in here and take a look at our startup. Now you'll see here we've made a couple of changes already. In this case, we're doing actually a couple of things different, right? So keep in mind that all of these adds, right? Add transient, those are builder patterns. So you can kind of chain them together like this, and it makes it quite convenient. But the other thing that we're doing here is this triad enumerable. And what I'm doing is I'm adding this iFund transfer service as an enumerable dependency, and I'm going to consume it as an enumerable dependency. So I'm going to go ahead and clear this out because I want to show you a little bit about how we use that. So in the fund transfer controller, this is actually consuming that IEnumerable of iFund transfer service. Do I know how many I have? No, I don't. And there's a couple of ways that this is useful. So in this instance, we're kind of using it kind of hokey. A factory would probably be better, but we're saying I'm gonna send in all of the fund transfer services, pick the one that is appropriate that will handle the fund transfer that you're doing. A factory dependency would be better architecturally, but this is just a demo. But you'll also see that we're passing in this iAccount logging. And I want you to watch this one, right? Particularly watch when it's created. And you'll kind of see what's going on, right? So iAccount logging gets passed in because we do logging. Now with the fund transfer service, notice that it gets passed in as an enumerable, right? And I'm calling to array, so that way I have an array of these services. And when I handle them, when I do it, get current balance after transfer. Yeah, see, I go ahead and I grab the implementation that handles a particular transaction type that I'm trying to do, right? So I have logic in here that knows which one to pick. And that's why a factory would be better. However, wouldn't demo quite as well. But I also want to show you, right? So we have this account logging, log account access. When we take a look at the fund transfer service, right? The fund transfer service and all the different flavors of fund transfer service. Well, most of them take in the account logging service as well, right? So we see iAccount logging, right? So we have an instance of a particular service that is used by multiple clients. So what I'm going to do is I'm going to show you the behavior of add transient, and then I'm going to show you the behavior of add scoped and how it works. So let's go ahead and I'm going to fire this up. And once again, we'll watch our debug window down here because it will tell us when all of these different services are being created. Go ahead and clear that out. Get some of that goop out of there. All right, so I'm going to come in, I'm going to do a fund transfer, and you'll see account logging service created, right? And then we have another instance of account logging service created. So we're seeing one request, I'm creating 2 instances of that account logging service. If I want to do an intrabank transfer, right, we have more instances of that account logging service getting created. I go transfer amount, right? Multiple instances again. Now keep in mind, this is per request, right? So it's not going to be per session. Hopefully you're not using ASP.NET sessions because sessions are bad, okay? It's not per session, it's not per user, it is per request when we go in and we do what we're going to do now, which is scoped. So let me come in here to my startup, right? So that I've decided I don't need an instance of the account account logging service every time I request it. In fact, it really should be scoped. And thank you, IntelliSense, for just overwriting all of that. There we go. So in this case, what I'm saying now is I only want one per request. And so you will see that account logging service is created once every time I make a request. So let's come in here. Again, let's clear out the goo. Now we remember when we come into fund transfer, we would see there's account logging, but now there's only one. If I come in and I want to do an own account transfer, right? We see account logging getting created again, but it's only being created once. Didn't do the transfer. Once again, that account logging service is created, but it's only created once. So that's once per request. If I stop that and I say, you know, really that account logging service, it's very much what's the term I'm looking for? Stateless, right? So I really just need one of them. It's kind of expensive for me to create the first time, and everybody can use the same one. It's re-entrant, so I'm just going to go ahead and I'm going to make a singleton of it. And I'm only going to create one instance of it. So we come in here. Let's clear that out again. All right, I'm going to come into fund transfer, and you'll see, here we go. There's that account logging service. It got created. Now, this is the first time I requested it, so it does need to create it, but it only creates it the first time. When I do interbank transfer, you'll see what's missing here. What's missing is that account logging service. It's not getting created again. And once again, account logging service is not getting created because it's a singleton. Even if I come in and I refresh it, right? When I went to fund transfer, that's when it created it that first time. It is now not getting created again. There is only one, and there can be only one. It is the Highlander. So those are some of the different lifetimes and some of the different things that you can do. Now, when it comes to ASP.NET applications, most of the time, probably 95% of the time, you are either going to use scoped or you're going to use transient. There are some instances where singleton is a good one, but for the most part, it'll be either scoped or it'll be transient. And just keep in mind that which one you're choosing. Don't just necessarily automatically default to transient because it may not be the right one. Don't just automatically default to scoped because that may not be the right one. Alrighty. So moving on, we have a number of special registrations as well. Now, these special registrations are things that are baked into ASP.NET Core, and they will handle some things for you. So first off, you'll have add DB context. So why would they do that? What's that for? Well, that is for a DB context for when you're using Entity Framework. The DB context gets added as scoped, so you'll create one per request, and it also handles disposal for you. And in fact, by the way, I'm surprised no one has asked this yet. If something is disposable, if you have a dependency that is disposable, it will automatically dispose of it for you. It will just handle it behind the scenes when it goes out of context. Add HTTP client. This adds an HTTP client factory and related services that you can inject into your components. Again, just like with DB context, this one is added as scoped, and it also handles the lifetime for you. One of my favorites has quickly become the add HTTP context accessor, which is quite a mouthful, but it's really, really, really super useful because it adds this interface called iHTTP context accessor, which allows for access to the HTTP context. Now, why is that so useful, right? Because HTTP context, I mean, we've used this all the time, right? It's just there. I want to do HTTP context.current, and I'm going to get my current context. Well, if you have stuff that you need to do with the HTTP context, and you try to unit test it, do you have an HTTP context in the unit test? No, you don't. So the HTTP context accessor actually allows you to mock out your HTTP context for your unit tests. So if you need to do things like checking on IP addresses or making sure IP addresses are getting resolved, or you need to do request.form or whatever you need to do with that HTTP context.current, instead of messing around with that, right, you have this HTTP context accessor that then abstracts that away from you and allows you to loosely couple to the HTTP context in a way that is more easily testable, right? You'll also have configuration. So there's an iConfiguration interface, and it's just there, right? Again, this is one of the things that ASP.NET Core just kind of bakes in and it throws in for you. And it's just there. But you can actually kick that up a notch. And you can kick that up a notch by using the iOptions pattern for typed configuration access. And it's kind of outside the scope of this talk, but there is a lot that you can do with type configuration and the way configuration works in ASP.NET Core. And iOptions will be there to give you that nice, rich, typed configuration access that we're used to from doing custom config classes in regular .NET Framework. So let's go ahead and take a look at some of these. What I'm going to do is I'm going to flip to my demo 4 branch. Force checkout, yes. Alrighty, so here we are, and now you'll see that we're going to be doing a couple of things with HTTP context, and we're also doing this, right? So let's talk about this one first. Let's do a little bit out of order, right? We're going to do configuration first. So you'll see that I have this typed config section. Now this is really super simple, right? But this is really here to kind of give you the idea, right? I have a type config section. I have these properties in here that I want to handle. I can never remember, you know, when I name configuration items by a string, do I declare them as constants, blah, 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 right? It's always just such a nightmare. I love typed configuration classes, so I do this a lot. Right, and this allows me to go ahead and inject that typed config section into my different services. So there's my type config section. I'm injecting it by saying services.configure, and then what the name of the actual what the name of the actual class is, the implementation class. This is typed config section is going to be, and then what section from the config file. Now this may be where you want to define a constant, right? So you might want to have that section as a constant. You might want to have it as something like in this case where it's just a string. It may vary, whatever, right? But right here we have get section type config section. So how does this work? So let's go ahead and take a look at my app settings. And in my app settings, well, hopefully, if you've been working with .NET Core, you've realized that we've moved away from the monstrosity that XML config files became to a new monstrosity of JSON config files. And the JSON config files are actually far less verbose and a lot easier to work with. But a lot of folks didn't use them as type configuration sections, right? They would just come in and they would do my property and then my value, and they would just do configuration my value. But you really have the same type of richness and the same type of hierarchy available in your JSON config classes that you would have in the old web.config, right? So you can do hierarchical ones, hierarchical config sections. This is our type config section, but they're a lot easier to define, right? Because you just say type config section, and my type config section is a JSON object with property name and num prop. So you'll notice that these right here will match the property names right here. And the way I set all that magic up is I come as a startup, not program, is this right here. And then what you will see is, and I believe I did it in the fund transfer controller. No, I didn't. Where did I put it? There it is. Here it is. You declare the dependency as iOptions, right? So here's iOptions. This is what it provides of typed config section. And then you go ahead and just pass it in. And so you'll see, and notice I have a breakpoint here. You call .value, and it will give you that strongly typed config section object or configuration object that I defined and attached to that particular section. So now in here in the actual code of my site, I don't have to worry about what the different section names are or what the different property names are or anything like that. I have it all typed. I have all IntelliSense for it, and I don't have to worry about it. And if I change the name of the config section for whatever reason, because my pointy-haired boss didn't like the name of it and it offended him or her, I only have to change it in one place. I don't have to dig around and see where that is and where it's hidden all throughout my application. I simply change it right here in the app settings. I mean, in the startup, right here. And then anyone else who's consuming this just uses it. HTTP context accessor, right? So this adds in that HTTP context accessor, and that we will see in our logging service right here, our account logging service. Or maybe not. Where did I put it? Oh, no, that's right. It's in the iRequest info service. Ah, see, I abstracted it. So my iRequest info service actually takes my HTTP context accessor right? Here it is. And so what I've done here is I have the interface for the request info service defined in my actual library. I have the context request info service. This is actually defined in the web app. So I don't even have to bring any of the ASP.NET specific dependencies into my library at all, right? I've defined that I have the service that will bring back what my current IP address is, and I have other stuff that's depending on it. In this case, right, my account logging service is depending on it. It needs to know what that IP address is, right? But how does it get it? It doesn't know. It doesn't care. And that's actually defined up here in the web project that is going to have the references to the HTTP context. So this keeps me from polluting my library classes with things like the ASP.NET HTTP context, where it, from a separation of concerns, it doesn't belong there. And once again, just like with everything else, I inject that service, right? So here is my request info service that's getting injected. And then I inject the HTTP context accessor. That HTTP context is sent into the request info service. And then when I go to get the IP address, I just return it from that current HTTP context. The consumers of it, they don't know that it's coming from an HTTP context or something else. They just know they need the IP address. So let's go ahead and look at the account logging service. And I will, you know what? I will set a breakpoint right here. So that way we can see it. And I also have a breakpoint, I believe it's here on the customer controller. There we go. So we can see our typed config section. So let's go ahead and run it. Alrighty, so we come in here to my account and we see the HTTP context accessor is getting set. And you'll see that it has the HTTP context. So this is my current HTTP context, right? Now we see this happening. Here's my request info service. Now the request info service uses that context. So when I come to request info service, I can see that the IP address is ::1. So that's, IPv6 for localhost. And then we see here in my customer controller, right? So it's getting passed in the options right here, config section. And we see config section. Let's go to .value, right? And you'll see number prop and property value. So this is actually getting read from that config section that I have and that I've defined in my app settings. My client class now has rich typed access to configuration. This, by the way, is I'm kind of harping on that because I don't see a lot of folks using that in .NET Core, and they just go and they just define everything kind of in this flat structure, and it gets really icky and really messy. When doing that is actually really easy, and it makes things that much more elegant and a lot easier to test as well. So let's go ahead and wrap it up because we're coming near the end. So we've looked at some of the hows and we've looked at some of the using it, right? One of the big problems, though, that dependency injection solves really revolves around unit testing. And the common problem with unit testing is, how do I handle these services that actually do stuff? Like, how do I properly mock database access, right? Do I start reading and writing from the actual database in my unit test? It's probably not a good idea, right? Because then your unit tests aren't necessarily repeatable, particularly if they change data, right? But they also allow the unit tests to really focus directly on the code that's really under test. They don't have to worry as much about, is this dependency, is the repository doing what it's supposed to doing? Is this other service doing what it's supposed to be doing? No, you focus only on the code that you're testing, because what you do is you mock out those dependencies and you say, okay, given that this dependency does X, then this thing should do Y. And you'll see how you can mock that. This plays nicely with both mocking and unit testing frameworks. You will typically want to use some sort of mocking framework. There's a bunch of them out there. I've used JustMock and nmock quite a bit myself. Now, the dependencies themselves, you want to supply them as part of the arrange step, create the mocks, and then certain mocking frameworks, most of the mocking frameworks will actually allow you to assert. So you can assert, I want to make sure that this particular dependency is called. So let's go ahead and take a look at introducing dependency injection and what it does with our unit tests. So let's flip over to demo number 5. I'm going to force checkout again. All right, so we've looked at the demo app and all that fun stuff. We've looked at our services, but let's go ahead and take a look at what we have new here, which is a unit test project. So in my unit test project, in this case, what I'm doing is I'm mocking out some of those services, right? The account service. Now, a real account service is going to go out to the database or do something or another, right? Typically, right? But in this case, I just want to make sure that when I call get current balance after transfer, that it is what I expect it to be given a certain set of conditions, right? So I'm going to say, I'm going to create a mock instance of the account service. And that mock instance, I'm going to go ahead and arrange it so that when get current balance is called for account number 111, it returns 500. So given that account 111 has $500 in it, when I do a transfer, after the transfer, it will return that the current balance is $400. So I'm controlling those underlying conditions, and I'm making sure that this own account transfer service is doing the right thing. Now, the other thing I'm doing here is I'm cheating a little bit. So one of the things that I've discovered that I really like to do is for complex objects, right? Instead of building them up and having all this code to create the object and that kind of stuff in my unit test, I like to make them as little JSON classes, right? And so I have this helper method. Let me go back. Here we go. Here we go. I have this little helper method that will deserialize file resources that are as JSON. So that way I have kind of this little library of sample objects that I can very quickly integrate into my unit tests. This also makes it really useful if you have a complex scenario where you have to build up, this very deep object hierarchy in order to execute a test. So you can actually go through, say you walk through the application, get it right to that point, and then you serialize that off onto disk as a JSON object. You can pull it into your unit test and then actually write your repro unit test to repro a particular bug that takes a whole bunch of doing to get to. Takes a little bit more work up front, but in the long run, it makes things a lot simpler. And then sometimes, I may go ahead and just deserialize. Okay, so I'll just deserialize this rich object tree, change 1 or 2 properties, and away I go. The downside to that is it's still something that needs to be maintained. So you do want to put some thought into it. But it's a way to keep things kind of nice and easy, particularly when you've got deep object hierarchies. So in this case, right, we're doing that. We're handling that get balance after transfer. We're creating a mock of the account logging service and all that kind of fun stuff. right? And you'll see this throughout. Bunch of mocks. We do the act. So I don't have to worry about whether or not that account service is created, whether or not someone else went in and mucked about with my test account that I use for all of my unit tests. Suddenly all of my unit tests break. But the other things that we can do is we can come in here and we can, for example, say, oh, right here, occurs once. So what this is doing is I'm saying, you know what, when they call the account service to get the current balance for 111, it should only happen once. I shouldn't call it twice. Now you'll see that this unit test is passing right now. I'm going to come into my own account transfer service and actually get current balance after transfer. And what I'm going to do is I'm going to cheat a little bit, right? So let's say I introduce a bug and I call get current balance a second time. And I don't want to do that twice because it's a pretty expensive operation, right? So this is going to be a bug. When I come back to my unit test and I go ahead and run my unit test, right? It's actually failing. And it's failing because expected at most one call so far two. But you'll also see I've got another one. Oh, so expected exactly one call so far zero, right? So what's that about? How did I introduce this bug in here? So what this is doing is it's asserting the account logging service. So in this case, I'm going to say I have a unit test where the account transfer logs account access. I want to make sure that account access is logged. Oh, somebody accidentally commented that out, me, and I forgot about it. Luckily, I had my unit test tell me that I failed that, right? I was no longer logging that account access, right? So it's not just, hey, the dependency does this, it returns that. It's also, am I calling it? Am I using those dependencies correctly? One of the other things that I like to do, particularly because I do logging pretty religiously, is I actually have like a full-blown test logger that I use as my dependency for logging, and I'll write that out to the test output, which becomes really useful for debugging and developing my code, because I develop most of my code actually through unit tests these days. So let me come in here, and I think there's that one. This one I need to fix also. So let me fix that one. Let's go back to my unit tests. Notice we have these failing. Let me go ahead and run them all. Let's see if I've got my bugs worked out. Yay! Okay, so now everything's working at least the way, at least according to these tests. Now keep in mind, unit testing isn't everything. You still need to do integration testing and that kind of stuff. But it gets you a really, really, really long way down the road to ensuring that your code is solid and working. And with that, there's one question I think that I did not answer in the course of the presentation, and that was oh, there's another question in there. Can I please post links to get started learning the basics of injection? Sure. I will actually go ahead and add a slide in here. So when I send this over to Mr. Steinberg, I'll have some links in here that I add in there. And yes, Spring Framework, there's a bunch of DI, IOC frameworks out there. There have been DI, IOC frameworks for full .NET framework for years and years and years and years and years. So yeah, it's nothing new. This is just how it's done in .NET Core, and finally Microsoft kind of got the clue, and it's just baked into .NET Core now. So when you deploy a DI service from dev to the QA environment, how do you make sure that the dependency service is registered? Well, it's the registration is actually something that you go ahead and you do in your code, right? It's not a separate step. It's in the code itself. Now you have to deploy all of the components that you require. So you need to make sure that all of your dependent components are there, right? But your dependencies are registered in your startup in here. So it goes with the code. It's not separate from the code. What is a framework exactly? A framework is a set of code, reusable tools to provide a certain task, right? So .NET Framework, bunch of reusable code to do a whole bunch of stuff. And there are a bunch of dependency injection frameworks out there that do a lot of the same type of stuff. This is just what is baked into ASP.NET Core. Alrighty. And with that, I think I went about 5 minutes over, which I think is a record for me. To sticking on time. I'm notorious for going even further over. So I think I'm doing good today. Thank you for joining in. I will post these slides. Also, when I post the slides, I will also post a link to the repository that I actually used for the demo. You'll notice as I went through the demo, I simply just switched branches. So I have multiple branches. I have a branch for each demo in the repository, so you can actually go through kind of the starting point for each one of the demos that we went through today, just by looking in the repository and looking at the different branches that are in there. All right. Thanks, everybody. Hope you all have a great rest of the day.
Thank you all for attending today's session. And Jay Sawyer, thank you as well for sharing. The recording of this session will be available at HoustonTechFest.com soon. We hope you all enjoy the rest of Virtual Houston Tech Fest and have a great day.